5, 7 roots and zeros. This lesson's all about how to find the roots and zeros of any polynomial equation, or most polynomial equations. So look at last lesson we talked about what a zero function is, right? When you plug something in and you get 0, we call that two things. We call it a zero of a function, and we also call it a root of a function, right? Because that means the remainder is 0. Because we learned that plugging it in, getting a 0 is the exact same thing as dividing it in remainder. So those things, so all these things are equivalent now. 0 of p of x is the same thing as saying the root. So 0 is the exact same thing as saying the root of a function. Because remember, if it's 0, that means remainder is 0, root. That's a factor. And if c is a real number, it's a real 0. If it's a real root, if it's real, then it's also an x-intercept. So that's only if it's real, though. It's a real root, then it's an x-intercept. So those are all equivalent. I could say 0, I could say root, I could say real root, factor. It's all kind of mean the same thing. Again, the only one that's a little caveat is if it's an x-intercept only when it's a real root. You're going to have some imaginary roots also, but if it's a real root, it's also an x-intercept. So, and then we have this correlation of fundamental theorem calculus, which I kind of brought up before. And that's this. Whatever the highest degree is of the polynomial, that's the number of roots you should have. Total roots, not real or imaginary, like a combination. So sometimes you have real, sometimes you have imaginary. That's how many roots you should have. So this is x to the 4th, I should have 4 roots. X to the 5th, I should have 5 roots. Okay, so let's solve a couple of these real quick and say them are zeros. What type of roots? So like this first one, I could factor this. This is x plus 3 squared equals 0. So I just solve this. X plus 3 equals 0. X equals negative 3. So this is, now notice this, you only have one root, but it's a double root. It's a double root. So there's one real root, but it's a double root. That's what makes it x squared. It's negative 3 twice. The next one, we can factor, so I should have 3 roots total. Just like here I had 2 roots total, it was 1 was a double root. So I should have 3 roots total. And the first thing you can notice, remember the first rule of factoring is always factor out what they have in common. They all have an x to make my life a lot easier. Equals 0, and I can factor this. That's x plus 8, x plus 4. 2 things I multiply, I get 32, but I have to get 12. Split each one, I get x equals 0, negative 8, and negative 4. So I had 3 roots, and they're all real. Now let's move on to the next one. Now we talked about a problem like this before. Remember, you can't just solve it normally. If you solve it normally, you're going to get this. You get x equals 2. It's only one root. It's not even a double root. It's x to the 4th. X to the 3rd power. X to the 4th. It's x to the 3rd power. So that's not right. What we have to do here is factor. That's not right. Should have 3 answers. Only have 1. So if you factor this using the difference of cubes formula, which again I will give you, it's always same, different, positive. So in this case, this is x cubed minus 2 cubed. So I get x minus 2, x squared plus 2x plus 4. And remember I said earlier how this part never factors nicely. You have to do quadratic formula on that. Or complete the square, whichever you prefer. So if I was in quadratic formula, it would be like this. 2 squared minus 4 times 1 times 4 all over 2 times 1. I get negative 2 plus or minus. This is 4 minus 16. Negative 12 over 2. So that's going to be negative 2 plus or minus 12 is 4 times 3 with an I. So 2i rad 3 over 2. Or divide everything by 2 and you get 1 plus or minus I rad 3. So you have that for this part. And this one's easier one. Skip that. X equals 2. So those are my 3 roots, right? I needed all 3 roots. X equals 2 and then plus or minus I rad 3. So in this case, we had 1 real and 2 imaginary roots. And that's the way it works, right? So I know right off the problem, right off the start, when I look at a problem like, okay, there should be 3 answers here, x cubed. And then when you solve, you could tell it's like, oh, 1 real, 2 imaginary in this case. So now let's talk about if I give you a generic polynomial I want you to solve. So let's talk about how we're going to go about doing something like this. So steps. 1, we want to graph this on our calculator to find the real roots, which are also known as x-intercepts. Once we do that, we're going to do synthetic division on one of them. Until we get an x squared, until we get x squared. And then once we do that, we either factor and solve, or use a quadratic formula. That's why we go down to x squared. Because there's no way we can't, so we can't use quadratic formula until we get x squared. And the easiest way to factor is into x squared also. So that's going to be our process. We're going to graph this, we're going to look for the real roots. Once we find the real roots, then we can use synthetic division to make our problem smaller until we get to x squared. And once we do that, we can either factor or use the quadratic formula. So let's get started with this one. Bring my calculator. I'm going to go to y equals, I'm going to type in my equations. So x cubed, I guess we're going to go down, plus 9x squared, plus 6x, minus 16. And I'm going to graph it. So you can see that now, actually from this one, you have your answers. It looks like it crosses perfectly at 1, crosses perfectly at -2, and it crosses perfectly at -8. So by looking at that, it looks like 1, -2, and -8 are my answers. Again, I only have 3 answers. That should be it. But let's double check. Let's do the steps like I talked about. If I'm doing that, right? Find a real root. So again, I just need to find 1 for now. We'll just use anything we want. Let's do a -2. I don't know, for the heck of it. Let's do synthetic division. So 1, 9, 6, -16. So I'm for effect, you can pick anyone you want. I'm gonna do -2. Again, I do not switch it because these are the roots. I just use them. You only switch it when it's like in this form. So bring the first one down, multiply across, add, multiply across, add, multiply across, and I get 0. So look, it worked. This is a root. Now what do we have left? Well, remember, it's always 1 power less, so this is x squared plus 7x minus 8. And then I got to factor this because I'm trying to find those zeros. So essentially we're saying this is equal to 0. So let's factor it. X minus 8, x plus 1. Other way around, x plus 8, x minus 1 equals 0. I need the middle to be 7, so the bigger term should be positive. And you get x equals 1 and -8. So those are my 3 roots. I got 1, -8, and -2. Just like I said from the beginning. So like, why did I go through this trouble? Because these happen to all be real roots. But what happens if you get 1 real root and a couple imaginary roots like we did up here? You're not going to find these on a graph. So that's why we need this process. We need the process to help us find the imaginary roots. The real roots are easy. The imaginary roots are where there are problems. So let's try that the next one. I'll tell you right now, this one, you're not going to have all the roots. I should have 4. Well, let's graph it and see what happens. So I'm going to go y equals, delete my old graph, put this new one in, minus 6x cubed, 6x cubed, plus 9x squared, plus 6x minus 10. Okay, all in there. Now look at this graph. All I get is this right there. I get 2 x-intercepts. It's x to the 4th. I should have 4 answers. I only get 2. And they're not double roots. They're not bouncing. So how does this work? Well, this is why we do the process, right? Based on the graph, it looks like it crosses at 1. I want to say -2. Even that, I'm not even totally sure. It looks like -2 to me. So this one we draw a graph. I think it crosses at 1 and at -2, but I didn't really see the tick mark. So it's either 1 and -2, or it might be -1. Anyway, so that's why we do this process. Let's find the rest. So 1, negative 6, 9, 6, negative 10. I feel very confident about 1, so let's put a 1 there. Bring the first one down, multiply across. So 1, add down, negative 5, multiply across. Add down, multiply across, down, multiply across. And again, I get a 0, so I was right. 1 does work. 1 down, 3 more to go. I need to find all 4. So remember, this is 1 power less. This is x cubed minus 5x squared plus 4x plus 10. Now, I'm going to use negative 2 because that's what I think it crossed that. I could totally be wrong about that. It could be crossing it somewhere else, but we'll see what happens. So use negative 2. Bring the first one down, multiply across, add, multiply, add, multiply. And I am wrong because look what happens. I get negative 6. I'm glad this happened though. Right? See how it's not a 0? Not a 0. So it's not a root. So it means it's not a, so it's not a 0, it's not a root, it's not x, it's none of that stuff. So negative 2 is wrong. It should be negative 1. So let's do it again with negative 1. So again, I'm going to use the exact same values right here because now I did it once, now I'm going to use x cubed. Don't go back to x to the 4. If you already broke it down, use this value. So we're going to do it one more time with x cubed. So it should be negative 1. Bring the first one down, so 1, negative 5, 4, and 10. Multiply across, negative 1, add down, negative 6, multiply across 6, 10, negative 10, and I get 0. So that one worked. Negative 1 was the right answer, not 2. And you get x squared minus 6x plus 10. So now this, remember we got down here, we got to solve this. So it's either factor or quadratic formula. This does not factor, right? Factors of 10, 1 and 10, and 2 and 5, that doesn't give me negative 6. So 2 options. I guess I got to solve this. I could either complete the square, it's actually pretty good to complete the square on, or I could do complete our quadratic formula. We haven't done complete the square in a while, so let me do that, because I haven't done that one. It's been a little while. So let's get the x squares by themselves. Okay, if you want to use the quadratic formula, go ahead. Just want to, I haven't done complete the square in a while, I want to flex my muscles with that a bit. Right, so you get this part by itself. Now we get the middle term divided by 2 and square it. Again, if you want, feel free to use quadratic formula. Add 9 to both sides. I get x squared minus 6x plus 9 equals negative 1. Remember, this always factors perfectly. That's the whole reason we do this. Right, complete the square is a little easier when the middle term is, if it's even, complete the square is pretty easy. If it's an odd number, never do it. It's ugly. Now we gotta solve this, because that's the whole point. I'm trying to find the zeros. So let's solve this thing. Take the square root of both sides. Square root of negative 1, that's I. So I'm gonna get x minus 3 equals plus and minus I. Add 3 to both sides. X equals 3 plus and minus I. So there's my two, that's my last 2 roots, right? All my 4 roots were 1 was the first one I found. Then negative 1, and now the 3 plus minus I. So 1, negative 1, 3 plus and minus I. All 4 roots. And again, that's why we have a process, right? That's why we know to just graph it and just put the answers down. Because sometimes you're going to have imaginary numbers, and those are not going to show up on the graph. So you have to do a process. So that's why we do that. I do want you to point out and notice a couple things. Notice eyes always come in pairs. You have 1 eye, you have 2. Always come in pairs. Because the only way to find I is by taking the square root of a negative number, so you get plus and minus. So that's why they come in pairs. Anyway, let's move on. So this part's going backwards. They're saying, hey, here's your roots. What's the polynomial? So, well, think about it, right? Let's go backwards. If 4 is my answer, what's the equation? X minus 4. Same thing with negative 1, x plus 1. And 6, x plus 6. Minus 6, sorry. And then remember, we have to multiply these out. So take it 2 at a time, multiply these first. This distribute. X squared plus x minus 4x minus 4. Add like terms. And then once you multiply that, then we can multiply by x minus 6. And again, just take it one step at a time. Multiply x squared by both of them. X cubed minus 6x squared. Multiply 3x by both of them. Minus 3x squared plus 18x, and multiply negative 4 by everything. Negative 4x plus 24. Add up like terms, you get x cubed minus 9x squared plus 14x plus 24. So that's it written backwards, right? So if you want to go backwards, just put them in their forms and then multiply it out. Or we do it pairwise. Now let's talk about i's. So we do the exact same thing for i's, but except for there's one thing about i's, and it's called the complex conjugate theorem. Like I mentioned before, i's come in pairs. So if you have one i, you're going to have at least two i's. So the way it works is they come in pairs of conjugates. This is why conjugates are so important. Remember what conjugates were was, if you have 2 plus I, its conjugate, you just change the middle sign. 2 minus I. Now the way that works here is, to have negative 2, 5, and negative 3i, I need its conjugate. Well, it's just negative 3i, change the middle sign, 3i. Right, the conjugate of 5i is just negative 5i. It's like 0 plus, 0 minus. So they always compare. So if you have a negative 3i there, you got to change this. It should also be its pair, 3i. And then the way this works, just like the other one, put that in this form, x plus 2, x minus 5. Put that one, x plus 3i, and the last one, x minus 3i. Now here's the one thing about doing this when you want to simplify it. Always do the i's together. Multiply those two together. I'll probably multiply these together also. Multiply these together first for sure. Because then the i's are going to cancel out for you. You're going to be happy. You get x squared plus minus 3ix plus 3ix minus 9i squared. These things cancel out. Remember when I squared equals negative 1. Negative 1 times negative 9 is positive 9. So that's the two i's multiplied together. I can multiply these together. I'm going to get x squared minus 3x minus 10. And then from here, so I'm going to multiply those two out to get an answer. Right, so I actually go blah, 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 blah. You get x to the 4th minus 3x cubed. I think minus 18x and squared, and then more stuff. Over here, how does this one work? Well, it's the same idea, right? So there's negative 4 plus I, and don't forget you need its conjugate to come in pairs, 4 minus I. So how do we write this? Well, same idea. X plus 4. Here's the part that's a little tricky. It's x minus parentheses 4 plus I. And, a little tricky, x minus parentheses 4 minus I. So that's how you would write it. Right? Because it's always, you always do the opposite. It's always minus. So minus, minus, minus. Right? Subtract that one, you get a positive. This is parentheses, so you get like that. Then I would multiply these together first. Simplify a little bit. X minus 4 minus I. X minus 4 plus I. And then you actually multiply these together. So x times x is x squared minus 4x plus xi. Then these plus minus 4x plus 16 minus 4i. And then finally the I. So minus xi minus 4i plus 4i, two negatives, and then minus I squared. I squared is a negative 1, so this becomes a positive 1. Right, and they just add up like terms. Negative 4x and negative 4x, so I get x squared. Negative 4x is negative 8x. The I should cancel out, and those two also. And I get 16 plus 1, 17. Right, so it turns out to be that. Like, it's not, it looks a little messy, but once you actually do it, stuff kind of cancels out for you. And then don't forget to multiply this by that part, and I'll do that part for you guys to multiply it out. But that's how you do i's. Key thing about i's, when I give you this, don't forget they come in pairs. Number one rule about i's is they come in pairs when you talk about roots. So remember, if I give you like negative 3i, there should also be a 3i there. If I give you 4 plus i, there should be a 4 minus i there. So i's come in pairs. Anyway, let's finish this off. A computer manufacturer determines the profit of producing X computers per day is given by this. How many positive real zeros, negative zeros, and imaginary zeros exist? What does the meaning of zeros in this situation? Again, we could do the positive, real, negative. There should be 4 zeros. I got a graph to figure out how many positive or negative ones are there. What is the meaning of zeros? It's not like what I care about right now. The meaning of the zeros, right? So remember, we have this, where this is something. So the zeros are where it equals 0. Right? 0 is not plug-in 0. It's where it equals 0. So P equals 0. And what is P? Profit. So the zeros of this problem is where the profit equals 0. So where you're breaking even in layman's terms. Right, so that's the thing I really care about. That we know how to do. We just graph it, figure out the reals, imaginary. But I care about this part, right? What does the zeros mean in this context of the problem? The zeros are when you're not plugging in 0, you're setting it equal 0. Very important. Zeros, you set the function equal to 0. Right, if I want you to plug in 0, if I want you to do this, that's initial value. Right, but if I want you to set equal to 0, I'll say find the zeros of the function. Again, what does that mean? So in this case, it means the P0, and P is profit, so profit 0. Anyway, that's the lesson.